Good morning, all of you. Anirudh sir, are you online?
Yeah, I'm there. I'm available.
Okay, sir, you can start now.
Okay. Very good morning, everyone. Thank you for joining on a Sunday. We'll do a quick recap of what we've done over the last 2 days. And then, as promised, I'll take you through some components of Amazon's web services. And then I'll show you how you can actually launch a machine, how do you connect to a machine, and all those things. Okay. Okay, so what I'll be talking about today is some of the features developed by a company called Amazon. So most of you would have heard this company called Amazon. So how are they working in terms of providing services to users to enable them to use IoT and cloud infrastructure and other components that are available on the cloud. Okay, so Amazon has been specifically working on IoT for the past 5 years. So they've been into the cloud industry for almost 20 years now. But into IoT, they started working on projects, beta projects, since late 2015. Okay, so they've seen potential on the IoT market. So I think the previous days that you would have heard that IoT market is probably growing to about $1 to $2 trillion of revenue, right? So that is the market that people are looking at. So Amazon started investing heavily in IoT infrastructure, especially in the areas that are shown on the screen. So the first one is energy, home automation, shipping, weather instrumentation, medical, similarly agriculture and security systems. Okay, so these are the different areas in which they saw potential for IoT. Okay, so where IoT can be used. Okay, so we've looked at some of the examples when we were talking about smart cities. So if you briefly categorize them, so one is health and life sciences, the smart city, and smart home. So if you talk about health and life sciences, you would notice that there's a growing concern that most of the people in countries like Japan and US and China, there's a lot of aging population above 55 and 60. So you cannot be with them full time. So you are using technology to actually give them more access to their daily needs. So assistance for elderly people and monitoring of condition of patients. So this is also very important. So you can't have a nurse having running it to the entire hospital. So you need to have some kind of sensors that can directly inform the nurse or the doctor when something goes wrong, right? So you have uh, monitoring equipments inside hospitals and control of conditions inside freezers. So this is also an interesting application where, so if you look at your normal fridge, right? So you have to control it manually. So whether if you have a freezer, you have to change the temperature of the freezer depending on what is the content inside the fridge or inside the freezer, right? So imagine if there are sensors that can detect what kind of uh, what kind of items are put into the freezer, and then it is able to monitor, or it is able to change the temperature accordingly, putting it into the right temperature, right? So that would be really smart. So you, let's say you put in ice cream, then probably the temperature would be at 2 degrees or 3 degrees or 5 degrees, right? So if you put in vegetables, probably the temperature automatically changes to something higher than 20 degrees, right? So without manual intervention, if you're able to change the temperatures in the fridge, so that is controlling the conditions. So we are talking about day-to-day usage. Think of where medicines are put. So some medicines need to be put at some specific temperatures, right? So let's say you change the medicine, the temperature also need to change automatically. So if something like that comes in, then I think there's nothing like it. So health and life sciences also have a great potential for this IoT market. The second one is smart city. I think we've all seen this day before yesterday, uh, and also in practice. I mean, even right now in cities where cameras are taking pictures instantly, and then the number plate getting identified, and then challans being given to the respective owners, right? So this is all automated. So we're already doing this in even in India, right? The other example that we talked about was parking spaces. How can you easily give the user where the empty parking space is available, right? That is an example that we've already seen before. The other one is detection of waste levels in containers. So this is being implemented. I think it's not in full fledged. I think in cities like Hyderabad, they've started doing this, where you put in trash into the can, and then once the can is full, then alert is sent to the GHMC people. So people come and then take away the trash. So if that was not there, then you need to have a manual person who comes in regularly and then checks if the uh, bin is full or not, and then take necessary action, right? So that is one thing. The other one was smart home. So inside the home, we were talking about water meters, we talked about energy savings, we talked about the automatic lights on and off, and one other thing is remote monitoring of security systems. So remote monitoring of security systems has also become more prominent everywhere. So you see a lot of people putting these cameras and then monitoring it, right? So having just cameras also need manual intervention. So it doesn't. So there you cannot proactively take any decision, right? So let's say you put in cameras in a shop, and then the shop gets robbed, right? So you take action only when the robbery is done, and then you notice that robbery is done, and then you go back and then see the footage, and then you probably try to find the people, right? Now imagine the situation where something irregular happens. Like for example, the shop is closed from night 10 to 6 in the morning, right? So you see some kind of movement in the shop, so that's an anomaly. So let's say some anomaly, whenever some anomaly occurs, you would probably trigger an alarm, right? So how can you actually find out this anomaly? So you can have a camera which can sense movement. You can have motion sensors which can sense the movement. Temperature also can help you find out, because if someone enters the room, there's a possibility that the temperature in the room will rise because he's breathing, and then you can actually monitor that. So having these sensors can alert the owner of the shop that something wrong is going on in the shop, and then uh, alert the required agencies, right? So that's the application of smart home. Now, retail and manufacturing also have been using the IoT. Uh, I'll just show you a small video developed by Amazon, so that you will get a sense of where technology can lead. So this technology is specifically in retail. So let's just have a look at that video. Is the okay? Okay, let's just have a look at this video.
4 years ago, we started to wonder.
So, is the audio visible? Is the audio? Are you able to hear the audio also?
Four years ago, we started to wonder. What would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So was the video visible and audio? Were you able to hear the video and the audio?
Yes, sir.
Okay. So what we'll do is let's break down what has happened, okay, and then see how you can actually develop. If you want to develop something similar to that, how do you develop that? So that's the goal of today's session. So we've seen an application. So the required hardware and the required software is there. All you need to do is come up with some kind of application, right? So where do you think this technology can fit in, and then you can just put in the technology. So like what was mentioned in the video, they were saying that they were using the same technology that was used in autonomous cars, right? So there's this technology already available. So they've looked at a problem in retail space, and then they're trying to come up with same kind of solution for retail space. So how do you so they're not inventing anything new. So they're not inventing anything new, and then they're just using the existing technology for a different kind of application. So our job would probably be to use the same kind of technology and then find an application where you think it will fit, right? So uh, so the benefit in current generation is you can use, all you need to do is just find the problem, like just have the problem statement. So once you find the problem, all the necessary infrastructure and facilities are already available, right? Okay, so that's the thing that we should be looking at. Just look at the problem. What is the problem that we're trying to solve? Okay, so what is the benefit of AWS is what we'll look into. So one of the major advantages of using AWS on the cloud is the scalability, right? So scalability, to give you an example, everyone had this problem of booking a train ticket during Tatkal, right? So whenever you log into Tatkal, you might not get into the home page, right? Probably there'll be a loading screen. And by the time you finish the loading screen and then do the transaction, probably the seats are over, right? So at Tatkal time, you would understand that there are a lot of people trying to access a server. So that is the load, right? And after 11 o'clock, you will not see so much load. So ticketing will be much easier after 11 or 12, right? So how does IRCTC handle a situation like that when it knows that at 10 o'clock there will be large number of users? So you have to increase the number of servers. So that is horizontal scaling. The same kind of server should replicate so that the servers are able to handle more requests. Another example is when you have this big billion day sales on Flipkart and Amazon. So they know that there'll be a large amount of requests onto their website. So only during that sale they would pump up or increase the number of servers, and then after the sale is done, they would again scale down to a normal number of servers. Like for example, let's say IRCTC during Tatkal time, IRCTC might have about 100 servers, but after the Tatkal time, they'll probably have 5 or 6 servers, right? So that's called scaling. So you scale the number of servers so that the number of requests the servers can handle will increase proportionally. Okay. The other thing is quality of service. So quality of service again is uh, instantaneous response to any request. Like for example, in a bank, when you're doing a transaction, they might ask you for an OTP, right? Let's say the OTP comes to you after 5 minutes or 6 minutes, right? So the request will time out. So it is important that whenever you click a button on the website, you have to get the OTP instantaneously. So there should not be any delay, right? So that's a quality of service. Ease of use. So ease of use again, if the application is not user friendly, if it's cluttered, then the number of people trying to use it also will not be high. For example, if you look at WhatsApp, right? So the application is very simple so that anyone from any age group can actually open WhatsApp and then share a message or send a message or record a video, send a video and all those things, right? If the application was complex, then people taking that application and then using it will definitely be less, right? Okay. Okay. So if you look at the architecture, like if you look at who stands where, okay. So if you look at the top is basically the application, the end user, right? So we looked at smart housing, smart houses, smart city, healthcare, retail, manufacturing, agriculture, and all those things, and power, energy savings, and energy savings, and all those things, right? So these are the applications. So what you look at is only one part of it. As a end user, you'll be having to deal with only the application part, right? So what goes below that? So when you make a request, again, we'll take the case study of what we saw, the Amazon Go product. Okay, so the application there is the app on your phone, right? So user don't have to bother about anything else. All the user had to do is open the app and then scan the barcode on the entrance, right? That's all the user has to do. So a lot of abstraction there. So the user doesn't have to know anything about what is going in the back. So So that is the application side. So what is happening after that is what is the remaining part. For example, if you look at the center part, right, the center, the orange one is actually given by Amazon, right? And at the bottom is the physical layer. So whatever the devices and all those things are provided by companies like AT&T, Juniper, Cisco, and all those things. So Texas Instruments, Broadcom. So all the sensor, the hard wired sensors are all manufactured by the embedded chip makers company like Intel and all those things, and the communication partners, right? So in our example, again, if you go back to the example, the bottom layer is made up of the sensors. So what are the sensors that we saw there? The first sensor was the one that is scanning the barcode, correct? So once you enter, there should be a camera that is tracking your movement, right? So there's a camera that's tracking the movement. The third sensor is when you pick up something, a sensor should indicate that an item has been picked. That's the first thing. The second thing is it also should indicate who has picked up that particular item. So like for example, we saw a lady picking up a cake. So you have to identify that a cake has been picked. At the same time, you should also identify that the lady has picked up the cake, correct? Because if you don't do that, so what would probably happen is instead of a cake, if you detect it incorrectly and then say probably juice, so there's a difference in price, right? So you have to be very accurate in determining what has been picked up. At the same time, you should also be accurate in who has picked it up. Like someone picks up a juice bottle, but then it's billed to some other person, correct? So that is also something which is very important. You have to identify the right person and the right product that has been picked up by the person. Okay, so far so good, where we have looked at what is the hardware part. Now once you picked up, once the sensor identifies the object and the person, what should it do, right? It should send the data somewhere. So transporting the data, you have companies as you see on the screen like Cisco, AT&T, and all, Vodafone, or the network carriers basically. So they help in transporting this data to some server, right? Some black box where all these calculations happen, correct? So companies like this help you to transmit this data. So IoT devices capture the data. The carriers help in transporting this data to a network device or a cloud server. Okay, so the cloud, let's say, is handled by Amazon. Okay, so what does Amazon help you? Amazon helps you in security. So no one can tamper. For example, let's say you have a Raspberry Pi device, okay, that is connected with sensors. So these sensors collect the data and then give it to Raspberry Pi. The Raspberry Pi sends the data to a cloud server. Okay, now this data secured, right? If the data is not secured, then someone can hack into it and then transmit the wrong data. That is always possible, right? So you have to secure that data. Now the other thing is, where should these cloud servers be available, correct? Let's say you're shopping in Hyderabad, so it's ideal to have servers within India so that the latency is less. So I think we had a discussion on this where we were talking about data security and data servers being within the country, right? So to get better latency, to reduce the latency, it's always good to have servers that are close to where the application is being hosted, right? So that locations are called availability zones, regions or availability zones. So you choose the right availability zones or regions so that this data that is collected by the Raspberry Pi is transmitted to a cloud server. Okay, now all these IoT devices transmit data in terms of streams. Okay, so you have applications like Kafka and those things which will actually get this data and then send it to big data applications, right? So you have heard of Hadoop and all those things where you can actually handle terabytes of data. Okay, so the data gets transmitted to a cloud server, and at the cloud server you have the solution, right? So Hadoop is actually by Apache, and you have MongoDB and then other web services that are available. So what these guys do is they capture the data and then take the necessary actions, what needs to be done. So once this is done, they'll again transmit back the data to the end user. For example, you picked up a cake, the quantity is 2, so this quantity and the product is actually billed to your account. So this is again done at the application level, and the moment that is done, once you come out to the shop, you would notice that on your phone, in your cart, you have these items, like very similar to what you do in a normal online shopping, you choose the item and then you say add to cart, and then the items get added to cart, and then you do the checkout. Okay, so instead of you manually adding items to the cart, here things happen automatically, right? Just to make things automatic, what is happening is you're using the help of sensors to sense and then send the data and then perform the same process that you're doing in online shopping. Okay, so now if you look at the overall solution, so we've actually broken down into different parts, and then we've actually seen what is done by whom. Okay, and then we're just integrating it into a application so that the user can use. Okay, so what is the most important thing is uh, identifying. So there the machine learning comes into picture, where you have to build a model accurately. So accuracy comes into picture. Here also again we've discussed about accuracy and latency. Should the model be more accurate, or is it okay that even if the accuracy is less, but you take between accuracy and latency, right? That is the thing that we've looked at. So should the model be more accurate and take more time, or should the accurate be less accurate and take less time, right? What is the trade-off that you have to take? So that all depends on the application.
Sir, are you audible, sir?
Yeah, I'm audible. Yeah.
Screen is not visible,
Video is not visible.
sir. PPT not
Oh,
visible.
okay. Thank you for bringing that up. I don't know why it did not. Is it visible now?
Now it is visible, sir. Thank you.
Okay. Yeah, I'm very sorry. I didn't notice that. Okay. Okay, so I haven't moved. I haven't actually changed any PPT. So this is the PPT that I was talking about. This is the slide that I was talking about. So the first level is the applications. Okay. So the bottom layer is basically the devices. So I was just explaining about how data moves from the hardware device to the application level. Okay. So just spend 5 seconds on the slide. So to understand. So devices capture the data, they send it to a cloud server, and on the cloud server you have some applications installed, and they take the necessary action, and then they send it to the application that is hosted, like for example your Amazon app, right? Okay, any doubts so far? Is the entire flow clear? Like how, if you have to develop an application, what are the things that you have to keep in mind, and then where you have to look for?
No doubt, sir.
Okay. Okay. Again, more detailed explanation. So device SDK. So device SDK is basically the SDK that is available on the devices. Like if you're using a Raspberry Pi or any other microcontroller device. So these are the device SDK. So I've talked about security. So AWS handles the security. Okay. So you transmit the data. You have something called as message broker. So I've told you that all IoT devices transmit data in streams, right? So you have message broker. So like something like Spark, if you've heard of Apache Spark and all those things. So they use this message broker. Okay. And then you have some kind of rules engine. And then you have the AWS services, right? Similarly, on the other side, you have the applications. Okay. So we'll look into one such example later. So what do you mean by the message broker? Okay, that's the first thing that we have to understand. What do you mean by a message broker? So we see that, so there are two sensors on the screen. So one is transmitting. Am I audible?
Yes, sir.
Okay. Yeah. So there's a power cut here. I don't know if I got disconnected or something.
The PPT is visible and you are also audible.
Okay. Thank you very much. Okay. So message broker plays an important role because all the devices keep transmitting data at the same time. Like for example, the shop example. So there are a lot of people transmitting. There are a lot of people doing the transactions, and then there are a lot of devices also trying to send data at the same time. So each device transmits data in terms of streams, right? So that's the reason why you need this message broker or to handle the stream data. Like for example, in one part of the store you have one device, in the other part of the store you have another device. So all these devices keep transmitting data at regular intervals, right? So how do you have to separate data coming from different devices, right? Okay, so the protocol that is used is called MQTT. So the protocol that is used to transfer data from the devices to the cloud is called MQTT. So it's a lightweight PubSub model. So PubSub model stands for publisher subscriber model. So I'll give you a simple example for a PubSub model for a newspaper. So if you take a newspaper, the newspaper guy doesn't come to your house on his own, right? So you have to subscribe to the newspaper. So once you subscribe to the newspaper, so whenever there's an edition, he'll come and then put the paper. So similarly, all the web applications also do something very similar. All your notifications. So you have to subscribe to a particular service, and then whenever there is a news, it will come. They'll actually send a message to your phone or to your email. You would also see this example in your emails. So you'll keep getting notifications, emails from different shops or different companies. And then if you click on unsubscribe, when you do unsubscribe, they'll stop sending you emails, right? So it means that you've subscribed to that particular group. And whenever there's a new post that is created by them, you will automatically get an email. So that is called the PubSub model. So they use this even here. They use something called as PubSub model where you register to a service, okay, and then when the service has some data, it will automatically transmit the data to you. Okay, the phone notifications and all those things also have actually also work in the same manner. Okay, so before MQTT was developed, we used to use something called HTTPS. I think you all are familiar with HTTPS, right? So so the difference between MQTT and HTTPS is HTTPS has a lot of headers around it. So the payload is like very high, okay? But MQTT is like very fast, and the payload size is very less because the amount of data that is transmitted is small. So it needs to be sent quickly so that the processing can happen faster. Okay, so if you look at the trade-offs between MQTT and HTTPS, it is almost 100 times faster throughput, less battery, and also less power. Right? So power is also of crucial importance because all these are devices that require low power, right? So if your network itself is actually taking up a lot of power and for processing, then your devices will come down much quickly, right? And also the network overhead. Like I said, the header, the package, the payload is much lower in HTTP. Payload is much lower in MQTT when compared to HTTP. So that's why there'll be more. There will be less network overhead. Okay. Okay, so the second part is authorization. So the first one that we saw was how the data is transmitted in channels or streams using something called as MQTT and its benefits over HTTPS. The other one is authentication. So how do you authorize this? Okay, so there are a lot of protocols that are in place to authorize. So HTTPS is one example where HTTPS is secure HTTP. So you use some kind of protocol, some kind of secure key management system to secure the data that is being transmitted. Again, you'll see this application in your WhatsApp. If you notice, about 1 year back, the message communications were not secure. So now if you try to transmit any data to a new user, you would see on the top that this message is secured privately or something like that, right? So now there's an end-to-end encryption in WhatsApp. So whenever you transmit the data gets encrypted directly on the application and then it gets sent on via HTTPS. Okay. Okay. The third part is the rules engine. So what do you mean by this rules engine and what does it do? Okay. So rules are basically used. You would have seen these rules in your normal databases, right? So what action needs to be done on what condition? Those are the rules. Like I said, you keep getting data from different sensors, right? So you need to take actions based on from where the data is coming from. So there you need the rules. Like for example, if you are getting data from Okay, another example. I'll give you a much simpler example. Let's say in the shop you have a section for kitchen, and then you have a section for home furniture, and you have a section for let's say food items. Okay, now if you can tell the database directly that the request is coming from a kitchen section, then you don't have to search the entire database. So it'll probably search only in data related to kitchen. Similarly, if the request or if the data that is coming in from the furniture section tells that I am the data coming from a furniture section, so the database don't have to check for the items from the entire database. It can just check from only the furniture section, right? Or you can split the data into database into three different parts. So one database handles only kitchen related items, one database identifies or has only furniture related items, one database has data related to only food items. Okay, so whenever you get a request, if you don't know from where it is coming, then you have to search all three databases, right? And that will take time. How can you avoid it? You can ask the device to tell from where it is coming based on its location. The sensor will send, okay, I'm coming from the food section. So immediately there is this engine that will transport this data to the database, which is containing only the food related data, right? So what we're trying to do is how can we ensure that the latency is reduced? So that is our end goal. When you build an application, all you have to look for is when someone places an order, how quickly can you resolve that order, right? So you have to think about ways in which you can actually reduce the time taken to process. So how can you reduce process is like the way I have explained earlier. So if a request is coming from one particular area, you redirect it to a database where only that particular data is available, so that the request is handled quickly. Okay, so once the action is taken, right? Once the action is taken, you want to store it somewhere, right? So there are a lot of places where you can store data. For Amazon, there is something called as S3, DB, SQS, SNS, Lambda, and all those things. So these are the places where the data is stored. Okay. So why do you need to store data? Like I said, if you have a lot of data, then probably you can get some meaningful insights out of that data, right? So like, for example, if I'm able to analyze the data and then tell one particular customer that he's shopping only in kitchen, then probably I'll give him more discounts on furniture and other sections like food, so that I encourage him to go to other sections, right? So I know that he'll definitely go to the kitchen section, but then if I give him discounts on other sections, then probably he may be interested in going towards the other sections, right? So you can give some personalized benefits to any user. So you need to collect data so that you can get some meaningful insights, right? Okay, so the other part of AWS is the EC2, RDS, and Glacier. So EC2 stands for, I think I told you the day before that Elastic Cloud Compute. So these are the machines that do the computation. So if you look at any cloud infrastructure, so how can you relate the cloud infrastructure? So I'll give an example of how you use your laptop. So your laptop has uh, three different parts to it, right? So one is your processor. When someone asks which configuration should I buy, you say take Intel processor with 4 GB RAM and then 1 TB hard disk, correct? So there are three parts. So if you look at any configuration of a system like a laptop or a desktop, there are three parts to it. The first one is the computation, right? So what is the processor? Is it an Intel processor? Is it a Amazon processor? What is the processing? You would say 1.2 gigahertz, 2 gigahertz, 3 gigahertz, right? So that is the computation power. Okay. The second part is your RAM. How much memory should the system have? So is it 4 GB RAM or is it 8 GB RAM? Is it 16 GB RAM and things like that, right? The other one is the hard disk, correct? So hard disk is do you want 1 TB hard disk or 2 TB hard disk? Okay. So these three parts on the cloud are three different instances. Okay, so they're not built onto one machine, but you can think of it as three different configurations. So on the cloud, you can choose your configuration. So you might need an application where you don't need hard disk at all, but you need a computation with like 4 gigahertz of computation power and 16 GB of RAM. You don't need hard disk at all. So you can get that particular configuration. So it's like supermarket. You go choose whatever you want and then use it for your application. Similarly, you can say, I just want a CPU with 1 gigahertz speed and 2 GB RAM and 30 GB hard disk, right? So you can choose literally what kind of processing power you want, what kind of RAM you want, what kind of hard disk you want or storage you want, and what kind of network also you want, right? So these are the things that you can configure when you're actually deploying a cloud machine. Okay, so this is again the rules engine. Will not look into that. So the last one is the applications, right? So in the example that in the video that we have seen, the application is the app on the user. So if you notice, the user has not opened his app. He opened his app only on the first instance and on the last instance. The entire computation is being done during his trip to the shop, right? So whatever we've discussed so far is going on in the backend, and once it completes, the user should be able to see what he has bought on the app, right? So that is the application that you have to build on the UI. Okay, you can relate the same thing to your security cameras also. So now you can actually see what is going on in your house on the phone, right? Something like that. So the app on the phone is basically your application. Okay, so just to reiterate, so what does the device do? It reports its current state, right, to multiple devices. The mobile app gets the final state of the device, right? So from the device to the app. So what we have discussed so far is from the device to the app, how is the journey? So that is what we have seen so far. Okay, so IoT registry, we don't need that right now. Okay, so again, every cloud service is paid. So Amazon also is paid. So this is all just the pricing part of how Amazon charges for the use. Again, the example for a smart device for Amazon is Amazon Echo. I think you would have seen it in multiple TV ads. So how Amazon works. Okay. So now what we will do is we'll have a look at how to deploy a machine, and then how to launch a machine, and then how to connect to a machine on Amazon cloud. Okay. Okay, any doubts so far? Okay, so I assume you have no doubts. Let me just share the screen. Okay, is the screen visible? Is the web page visible?
Yes, sir. It is visible.
Okay, great. So the website is called aws.amazon.com. So you have similar websites even for Microsoft and Google. So Microsoft's cloud structure is called Azure. Google's has Google Cloud. IBM has its own cloud. Okay, so what we'll be looking at is only Amazon. So once you open this website called amazon.com, so there are under products, you can see a wide plethora of services provided by Amazon. Okay, so these are the different services that Amazon provides. You can look into this in detail. You can just go to their website and then see. And then you have something called as pricing. So different solutions by use case. Okay, so they also give you the entire infrastructure as a whole, right? So it's called like containers. So if you have to develop a web application, so what is the required hardware? Whatever is the required hardware, they'll give it you everything in one shot. So you don't have to create individually. Like for example, you see there's an application for blockchain, so they'll probably give you end-to-end suite for blockchain application. Similarly, if you have to migrate something or some container services, they'll give you this end-to-end suite. Okay, so they have the solutions by predefined for you, pre-built for you. Okay, and pricing. Okay, so if you want, you can just have a look at the pricing, how they charge you. I think we'll just have a look at one of the small examples. So EC2 is called Elastic Cloud Compute. So they have these services called on-demand and spot instances. Okay, so we'll just look at Linux services. So since we are in India, we'll look at the services here. On the left hand side, so the first column indicates the kind of servers that they have provided. So what are the servers that you can launch? Okay, so the second column indicates the number of CPUs that you can have with the corresponding name. Okay, and then the memory and their charge. So if you look at a machine called T3.x large, okay, so it has 4 CPUs, quad core, 16 GB RAM, and then it charges you 0.1792 per hour. Okay, so 0.1792. So how much does that per day come to? So that's like $4.3 per day. Okay, and per month it will come down to around $130. That is approximately 9,000 rupees. Okay, so if you have to have a server that is quad core and then 16 GB, you need to spend about 9,000 rupees per month. So that is the cost. Now the benefit of this is you can just launch it, since they charge per hour, right? And your application needs to be live only for 1 hour or 2 hours. So you can just launch it. Once your use is done, you can just terminate the machine. Okay, so you'll be charged only for that particular hour. Okay, so for 1 hour, $0.1792, and then that's it. So you don't have to pay for a month. You don't have to rent it for a month or 2 or something like that. So that's the benefit of having these cloud servers. So you can just launch once your servers are done. Once your service is done, you can just terminate the machine. Okay. So similarly, you have Windows machines. The costing for Windows machine is higher because you have to pay for the license for the Windows. Okay, it's not much high. It's a bit higher. So for example, if you look at the same machine, it's $0.1722 per hour. Okay, so this is the pricing for the machines on Amazon. Okay, so pricing varies with Amazon and Microsoft. So it's better you choose whatever is the right pricing for you. Okay, so let's just sign into the console. Okay, so once you sign into the console, you would probably see something very similar to the screen that I'm looking into. So on the left hand side top corner, you would have this services option. Okay, so these services are the same thing that we saw on the first dashboard. Okay, and we also talked about the screen day before yesterday, where AWS has provided you with an entire suite for IoT devices and IoT infrastructure, right? Similarly, there's a different suite for the compute. So the compute is basically the CPU. So what is the kind of CPU that you want? Okay, so it also has inbuilt RAM and all those things, and all the storage is S3. Okay, and databases, you have different kinds of databases. So if you have heard, there is something called as SQL and NoSQL databases, right? So relational databases and key value pair databases. So you can launch whatever kind of database that you want. So based on your application, you can actually spin up any machine that you want. Okay, so for today, what we'll do is we'll see how to actually launch a EC2 machine. So let's click on EC2. Okay, so I already have one instance running. So if I click on instances, okay, so there's an option called launch instance. So I've recently launched a web server for the college. I'll show you that application also, but for now, let me just show you this. So I'll click on launch instance. Okay, so once you click on launch instance, you would see these options of what kind of server you want to launch. We've already seen the pricing for Windows and Linux, right? So here, if you see, there's something called as free tier. So you click on free tier. Free tier gives you a free 1 year option to launch machines. So these shows you what machines are free for 1 year. Okay, so you can launch a Red Hat machine, SUSE, Ubuntu. You can also launch a Windows machine. Okay, so let's just launch a Ubuntu machine. Okay. So just click on, or let's launch a Windows machine. So I'm on a Mac. So let's just launch a Windows machine so that I can just connect to that and then show you. Okay. So once you click on select, what is the machine that you want to launch? So T2.micro. So T2.micro has 1 CPU and 1 GB RAM. Okay. So go to the configuration details. So it'll ask you what is the network structure that you want, and then it'll ask you for the storage. What is the storage that you want? Okay. So right now it's 30 GB. Okay. And then if I just click on review and launch, so I just have to review the systems. Click on launch. Okay. Okay. So I've launched the instance. It will take a while to come online. In the meantime, I'll also launch a Linux machine. So it's important that when you launch a machine, be aware that the machines are chargeable, right? So once your job is done, make sure you go back to the console and then terminate the machine. Okay. So the one machine is running, but there are some initialization still being done. The other machine is still pending. It's still initializing. So I'll show you how this machine looks. So Bits Web is actually a remote Linux machine that we have created. So I'll show you how to connect it. Give me a moment. Okay, so now I am actually showing you my terminal. Okay, so we have launched a machine called BitsWeb. So how do you connect it? You just have to do a simple SSH. Okay, so on the left hand side you would see this is my machine. Okay, so this is a certificate that is needed, and this is the address of that machine. Okay, this is the address. So if I just do an SSH, you'd see that now on the left hand side, the name has changed to Ubuntu at some IP address and things like that, right? So I'm actually in the Linux machine that has been launched, right? So this is how simple you can actually launch a machine. Okay, so to connect to a machine, you just have to do SSH. You can just connect to the machine. Okay, so what is hosted on the website? So now once you're on the website, you can actually install whatever tools you want. So the purpose of creating that machine was to actually show a course page, right? So we had to show a course page, and that's the reason why we had to launch that machine. So I'll show you that course page once again. Are you able to see the course page?
Yes, sir.
Yeah. So this course page is what we've designed, and this is actually hosted on a server, on the Amazon server. So all we had to do was spin up a machine because we were not able to access servers on the campus because all the servers had private IP. So we had to host a public IP, and it was a challenging task for one of the guys in the college to do it. So what we did was we hosted one server on Amazon, and then we designed this course web page and then hosted it so that everyone, all students can actually see the web page, right? So how do you terminate? So I'll show you how you can actually terminate the. Okay. Now, if you see, both the machines are actually up and running. So, if you want, we can just connect to a Windows machine also. So this is a Windows machine that we have launched. So let's just try connecting it. So Windows, you cannot connect through SSH because it's a Windows machine, right? So you cannot connect it through SSH. So what you do is you have to use a software third-party tool called Microsoft Remote Desktop. Okay, so I'll show that once. So on the what you need to do is something called get Windows password. Okay, so once you give the required certificate, it will give you the password. So this is the password. Okay, so the tool is called Microsoft Remote Desktop. Okay, and so here PC name, we have to give the PC name, the whatever we have launched. You have to give the name. Okay, so the name is this one. Okay, so once you click on demo 2, okay, spelling is wrong. Can you see the Windows machine being launched? Can you see the Windows machine now? So if you notice, we just launched a Windows machine. So I've connected remotely to this Windows machine. Is the screen visible for the Windows machine?
Yeah, yes, sir. Visible.
Yeah.
Yes,
Yeah.
visible.
Okay, cool. So if you see on the right hand side of the screen, you have the instance, whatever we've launched, t2.micro, total memory, whatever we've done. Okay, and then the public address and and the private address. So now you have a Windows machine at your disposal. Whatever you want to do, you can do on this machine, showcase it for a demo or something like that, and then you can always go back and terminate the machine. Okay. So you don't need to buy hardware physically, because if your application is short term, you can have it for short term. If your application is long term, then probably choose your pricing in such a way that it comes down to your cost and then launch machines on the cloud. Okay, so that's the benefit of having applications or applications developed on the cloud. Okay, okay. So if you go back to the console, the public DNS is this one. So whatever instead of IP address, what you have to give is this one. So DNS name. So this is what you have to give while connecting. So this is the same thing that we've used to connect using SSH. So SSH, the key, and then followed by this IP address, and then you can connect. So similarly, you can connect to any of these machines. So if you have to terminate the machine, all you have to do is click here under Actions. You have this option called Terminate. You can just click on Terminate. Okay. Similarly, if you have to terminate this, Actions, terminate. Okay. Okay. So similarly, so EBS is basically elastic block storage. So that is like your hard disk, right? So you can increase or decrease the hard disk according to your this thing. One interesting thing here I wanted to mention here is something called as load balancer. Okay. So load balancer is like your traffic police. So like I said, if you have to increase the number of servers or decrease the number of servers, so that can be done by load balancer. So if you have to increase the number number of servers to 100. So there should be someone sitting on top to send each request to one of these 100 servers. So, right. So that guy is basically the load balancer. What he does is he'll see the number of servers and he'll actually make sure that the traffic is split across all these 100 servers. So that is what the load balancer does. So, and the other option is called auto scaling. So auto scaling is the same example that I was talking about IRCTC. So you can actually specify the time and then say that at this time you increase the number of servers to 100 and at this time you decrease the number of servers to 5. So even that is automated. So you don't have to have any manual intervention. You can configure things like that directly. The other kind of configuration is if the number of requests increase by certain number, you launch another machine. If the number of requests decrease by certain number, you delete a machine. So that also is configurable so that your entire process is now automated, right? So the system will take action based on whatever rules that you have given. Okay, so once you give the rule, it will follow that rule and then launch or terminate machines according to the rule that is given. Okay. Okay, so that's all I had for today about talking about Amazon, its services, and then a small demo of how to launch a machine, how to connect a machine. If you have any questions or queries or want to ask something, just let me know. I'll be more than happy to answer them.
Anirudh ji,
Yes.
who is the competitor of Amazon in
Hmm.
India other than Google and means this Google is one of the competitor. Then Amazon is one. Geo and any Indian partner is there?
No, sir. Actually, currently there is no market competitor for Amazon. So, Amazon is a monopoly. Only from 5 years back, Microsoft has started pulling into Amazon's territory, but Amazon has been there in cloud for almost 20 years. So, as of now in India, definitely there is no competitor. So there are small startups providing the space, but it's definitely no competition. So Amazon is like a whale.
Earlier, it used to be VSNL. You might be knowing VSNL and other data center services used to be provided. So Amazon has their own data center in India, or they
Yeah,
are
yeah, yeah.
okay.
So, okay, if we're talking about data centers, so BSNL and all these things have their own data center. So they have not migrated to cloud. So a lot of companies have their own data center. Like for example, if you take, let's say, all the healthcare and all those things, they have their own data center. What Amazon does is they have outsourced their data centers for others to use. Like for example, if you heard of this, have you heard of any gaming applications? Oh, okay, let's take this example of Flipkart. Okay, so Flipkart has this their web servers, right? Their data centers and all those things are now on Microsoft platform. Okay, similarly, some companies host their servers on Amazon. So they don't have their own data centers, but they have this. They have used Amazon servers for launching their applications, right? So companies like BSNL, they have their own data centers, but they don't outsource it to them. So Amazon makes money by providing services like this. Did I answer your question? I think I was a little vague.
No, I am able to understand. We have used the data center services of BSNL earlier. Now it is Tata Telecommunications, something else. So I have
Okay.
understood that they are providing data center services on their own servers
Yes.
to the customers who wants a, small space, who wants a big space, who wants a
Exactly.
like that only.
Correct. Correct. Yes.
So what is the see that configuration and all those things have been given. The main configuration here is the billing.
Correct. Yes.
How the billing is means transparent. That is the main thing that we have faced in the earlier part. Means you have talked about that
Okay.
something 9 rupees is given and something like
Yes.
that.
Can you see
How
the
that
screen?
transparency is built in.
Can you see the screen?
Yes, screen is visible.
Yeah, let me show you my billing page. Okay, so I'll show you how transparent it is. Okay, so this is the breakup of my billing page. Okay, so how much I am billed. So from the month August, this is what I am billed. Forecast for August is this month. Okay, so on the right hand side, it shows me how much I've spent for the EC2 machine, and then how much I've spent for the other services, and what is the tax for it. Okay, so you can actually see per machine to machine base also, like how much each, how many hours I've used. So for example, so if you see here, so I've used 351 hours of Linux micro instance, and I've used 1 hour of Windows machine, and then SSD for some. So this is 435. So you can compute this 435 by going to your price page and then multiply that price per instance into this number of hours. So it will give you this much. And that is what you're supposed to pay. So the transparency is very high. So you don't have to worry about transparency, especially in Amazon.
Very nicely and insightful presentation, Anirudh.
Thank you, sir. Thank you very much.
And I think AWS is going to rule the world. In India, it's nice to see this type of services.
So Microsoft is also doing great. I think after Satya Nadella came in, he's concentrating a lot on the cloud. So it's actually taking away a lot of profit from Amazon Web Services. It's doing really great now, Microsoft.
Can we have a copy of presentation of all the 3 days?
Yeah, sure. So most of the PPTs are all freely available. I can just share it with you. So the Amazon slide is actually from Amazon. So it's not something that I have prepared.
Okay, that's right.
Yeah,
But
I'll
other
share it.
than
No problem.
IoT and IoT are also insightful, so that will help us in future. That's the
Sure.
reason.
Definitely. Yeah, I'll share them.
Thank you.
Okay, so if there are no other questions, then probably I think we can
Hello,
break.
sir.
Yeah, go ahead.
Am I audible, sir?
Yeah, you're audible. Go ahead.
Sir, you told about that Raspberry Pi about latency, no, sir?
Correct. Yeah.
Latency. Actually, sir, this latency generally varies from device to device or environment, sir.
So device latency. Okay, so there are two things that you have to talk about here. So when you say latency, uh, computation also matters, right? So if you're doing more computation on the device, there is an increase in latency,
Okay.
right? So that is one kind of latency. Like for example, if I ask you what is 2 plus 3, then you would say immediately it's 5, correct? But if I say what is 22 into 3 into 45, you would probably solve it, but you will take a little more time to answer the question, correct? So that is latency in terms of computation. The other latency is in terms of network, correct? So if I have to fetch data from, let's say, okay, other example is if you have to go fetch something from a shop very close to your house, it will probably take 5 minutes. But you have to go to a supermarket and then come back, it will probably take 30 minutes, correct? So that is your network latency. So similarly, if the server that you are talking to is within the premise, then the Raspberry Pi talking to the server and then coming back, the response coming back is very small. But similarly, if the server is placed in the US or some other place, the latency, the network latency will be higher. So the total latency will be both computation plus network.
Sir,
So,
is any other alteration to reduce that network latency, sir? Any alterations?
Yeah, you can use. So see one thing, so that is where the edge computing comes into picture. We've talked about edge computing on first day or second day, right? So instead of sending it to the cloud server, let's say you have a local server, right? Where the local server is also capable of doing some kind of computation. So we've literally reduced the latency of network by half, or maybe 10 times, because the latency is 10x. Device to edge, the latency is 10 times slower than device to, is faster than 10 times slower to device to cloud. So you've reduced your latency by 10 times. So that's why the edge computation is picked up pace. So that is one way of reducing the network latency. How can you improve the device latency? By bringing in powerful devices compared to Raspberry Pi. If Raspberry Pi has, let's say, 1 GB RAM or 2 GB RAM, you're able to come up with devices that have 4 GB RAM or 5 GB or 6 GB RAM, then your device latency also will reduce, right?
Okay, sir. Another question, sir.
Yeah.
What about the security provisions in Amazon Web Services, sir? And how much it is secured while doing any transactions?
Yeah. So Amazon is not secure. Okay. So Amazon will not tell you that we are secure. Okay.
Yeah.
But it will provide you with the applications that can make sure that your application is secure. Like, for example, you have the option of using HTTP as well as HTTPS. Okay. So it is up to the user to use HTTPS to maintain security. So you cannot tell I'm using HTTP, but Amazon is not giving me security. So Amazon is like a supermarket. You go to the supermarket, you choose whatever you want. So he will not tell upfront that I'll provide security. No matter whoever attacks this box, I am responsible. He will never do that. So another example is, let's say you have a machine and you have opened all the ports, right? So what will Amazon think? He thinks that probably the user wants the application to behave in such a way, right? So you have to make sure that, one second. So you have to ensure that the necessary ports are closed, only the required ports are open, right? So Amazon will not tell you that, okay, you know what, all these ports are open, someone might attack you. So it will not tell anything like that. But I think right now it'll probably warn you, saying that your server is too open. Should probably put some restrictions on the ports. Similarly with antivirus, so it's your duty to install some antivirus on the Windows machine, on the server. You cannot tell that Amazon will protect your machine. So that is something which Amazon will never tell. But what Amazon will guarantee is, if the server is online, it will make sure that the server will remain online.
Okay.
Got it? So you will never see a network failure or a request failure like that. So from hardware perspective, it will ensure that whatever you have launched is running.
Okay, sir.
From security point of view, it's up to you. So
Okay. Any more questions from the
anyone who's
participants?
interested, I think just log into Amazon console, try launching it, look at some documents, and then it's a good practice to understand how things work, because everything is on the cloud now. Everyone is asking about people who worked on the cloud. Even in government jobs, they were asking to have certifications cloud and all those things. So one thing from the learning perspective, it's very interesting to learn all these things, because you will get a good understanding of how things work. And from career perspective also, I think it's important you know all this stuff.
Any more questions from today's session?
Okay. Before presenting the vote of thanks, I would like to hear the voice of participants about this workshop. If anybody wants to say something about this. Yeah.
Sir, good morning, sir. Sir, am I audible?
Yeah. Are you
Good
asking the
morning, sir.
question?
Actually, Sir, no, sir, not question about the feedback only, sir.
Okay.
Actually, attended nearly 2.5, 3 sessions only, sir, because of network issues, actually.
Okay.
But all these sessions are very informative sessions, sir. Especially that wireless communication 5G. Actually, I put a minimum 3 to 4 queries on that day, but I got excellent answers from the resource person.
Okay.
And these sessions are very informative, and moreover these sessions are very useful for research aspects also, sir. Thank you very much, sir, providing conducting this type of FDPs from the VKR and VNB college. Thank you very much for both for the resource persons and organizers. Thank you, sir.
Thank you so much, sir. I think you are morally right, sir.
Yes, sir. Yes, sir. Yes,
We
sir.
observed that from the beginning onwards, you and one more person is very actively participating in these sessions, and another person named.
Yes, sir. Thank you, sir. Thank you very much.
Anybody wants to say something?
Am I audible?
Yes, sir.
I just wanted to congratulate VNR for this second session. The earlier session or the 5-day training program, they had given it, I think, 1 week back on on Python and one more technology. That was also great. And this one, the earlier session by Dr. Sanjeev was on technicals, and this Dr. Anirudh's session on IoT and 5G was excellent one. I just wanted to congratulate them, and I just wanted to say to them in future also they may organize sessions like this, because these sessions give us the new know-how of the new technologies that are going on in India and world over. And outside, we won't be able to hear about these technologies. The people outside are not able to explain to us in that depth what they have explained it to us. Their resource personnel are very insightful and have a complete knowledge about their subject. I just wanted to thank VNR and their resource persons. Thank you.
Thank you so much, sir. Any more? Okay. Now I request Professor C.H. Sri Lakshmi Garu, ECE HOD, and also convener for this workshop, to present the vote of thanks. Madam, please.
Okay, sir. Good afternoon, everyone. I am honored to have the opportunity to give a vote of thanks on this workshop. Firstly, I would like to thank Sri Sanjeev Garu and Sri Anirudh Garu, who shared their knowledge to all the participants on 5G communications with IoT, along with IoT applications. On behalf of all the participants also, I would like to thank these two resource persons, Sri Sanjeev Garu and Anirudh Garu, for their wonderful explanation and in-depth explanation. Next, I would like to thank Sri Vikram Garu, who extended his support in conducting this type of workshops and encouraging us. Next, I would like to thank our principal sir as well as management for encouraging us to conduct this type of workshops. Last but not the least, I would like to thank my faculty friends who contributed to this in organizing this workshop, all the faculty members of ECE as well as CSE who has contributed their effort in organizing this workshop. Last but not the least, I would like to thank all the participants for making this event a grand success. And we are very happy to listen the feedback on these workshops, which we conducted earlier and this one as well as. Thank you very much. Thanks one and all.
Okay, thank you, ma'am. And one more instruction to the participants. We'll share the feedback link in that group we have, Telegram group. So I request all the participants to fill that form. Okay. Thank you so much. And once again, thank you all the participants and resource persons. Thank you. Bye.
Thank you.